Yes.
So when I get home, it's my phone instead.
Instead, you can. And then also, will sometime today, whenever you get home and you fill out that form, I need you to register for AP Classroom.
Classroom?
Yeah, it's that paper I gave you y'all yesterday that looks like this. And if you need another copy, you can take this one. I need you to use your fourth period code and sign for it. That way you can register to take the AP test when the time comes. Thank you. While y'all are doing that, I'll finish up attendance on my end, and we'll be good to go. Anyone need more time doing the connection form?
I don't see it.
You don't see it? It won't be in Blackboard. You'll have to scan with your camera, scan that QR code up on the. Or you can type in your browser, type in that link where it says scan the QR code or access this link.
What about the attendance?
The attendance, that should be in Blackboard. Let's see. Okay. That's there. Go to courses. Yeah, fine. Go to course content. Content. Sorry, I'm not really that familiar with the app. How the app works. Okay, so while y'all are finishing the two forms up, This will probably have to wait until tomorrow. I'm going to, and this goes more for dual credit than AP. I'm going to post a video under the content folder in the class info on how to link your AC email and your LHS email. We tried it third period and come to find out you can't do it on your phone. You have to be on a physical computer. So tomorrow in here, we may have laptops. I know my first and fifth period should have laptops. I'm not sure if y'all will. It's not mandatory that you link them. As long as you have access to them and you check on both, that's all that matters. So I'll post that video. You can watch it. It takes you step by step through how to do it from a computer. And then we'll go from there. Okay, let's see here. See if there's any questions. For those of y'all that are virtual joining us, if y'all have questions, just feel free to put them into chat. Okay. Anyone still need me to leave that barcode up there? Okay, so I'm just getting everything set up to start lecture. But first, I'm going to talk about all of the handouts y'all received. I gave y'all a few of them. Okay, there we go. Okay, so first I'll start with AP. The formula chart that y'all have. This is that one I talked about yesterday that I said I'm going to give to y'all. And you get to use it all semester long. For these first two tests, it probably won't be helpful, but I'm not going to say you can't. And you have your, if y'all have that AP contract, I'll take that as well. And then, so that was the formula chart I'll get to use all semester and on the AP test. Everyone, AP and dual credit, was given a packet of the notes. So when we do notes, they're going to be fill in the blank for the most part, because let's face it, statistics is very definition heavy. And I wouldn't want to sit here and write every single definition, and I wouldn't expect y'all to either. So the notes will be fill in the blank. You can add as much as you want, you can add as little as you want. It's up to you. So that's the notes packet that says chapter 1 for dual credit. I gave y'all formula chart. Many of you probably sat down and looked at it and you're like, oh, good grief, what does all this mean? Don't worry about it for now. Keep it in a safe space because you don't want to lose it. This is your one copy that you'll get this semester of that chart. If you don't mark on it or make any notes on it, you'll be able to use it for basically any test. Test 1 all the way through the final. So that's what I'm saying. Keep it. If you have a folder or something, I'll keep it in that folder where nothing will. Now, a freak accident happens. You spill Dr. Pepper in your backpack, and Yeah, it's not like you just, oh, I'm going to pour Dr. Pepper in my stats folder to ruin everything. I mean, then yeah, I can get you another copy. But if you just, oh, I clean my folder out and throw it away. Oh, sorry. And then I also gave y'all a PDF of your homework. It's the same one that's going to be in Blackboard that posted this morning. And what I did was I put, so if you took this class at AC, you would have to buy an access code to something called My Math Lab. Well, we didn't want y'all paying $100 for a code that would only be good a semester. So what I did is I printed out all their assignments that they would want me to assign y'all if y'all were there. Took them all, turned them all into Blackboard assignments. But then, since y'all are here, I'm also giving y'all a paper copy of them. With that being said, the paper copy is more for you. I want y'all to put all your answers in Blackboard. Does that make sense? And then, for the reason I mentioned yesterday, it grades it instantly, and you get 3 shots to get the highest grade possible. I mean, if you just turned in your paper copy, I probably wouldn't grade it instantly. And then by the time I get it back to you and everything else, it may be past the due date. So, I went on and gave it to y'all. That way, if you wanted to take what we've done tonight and try to work on it, you could. For AP, y'all's homework is in the book. So if y'all want to go in and write this down, it'll just like theirs. Everyone's first assignment is due Thursday. Y'all's are problems 1.1 to 1.9 in the textbook. And that'll be due on Thursday. (1.1 to 1.9). Mm-hmm. So that's the section. 1.1 to 1.3. Section 1.1 to section 1.3 is like the section that sections we're covering. The actual problems themselves are 1.1 to 1.9.
Oh, yeah.
Yeah. And it's also in Google Classroom, if you haven't looked there yet. And then it's also in the calendar in Google Classroom. So I'm trying to put them all over the place. That way y'all can find them easily. Okay, so before yesterday, when you heard statistics, what did you think? Or when you signed up for this class, what were you thinking you were getting into? Something related to data science. Good. Probability. Yep, that's a good one. Economics. Yep, they use a lot of statistics. Trends. Yep. So those are all uses of statistics. So what is it? It's the scientific discipline that provides methods to help make sense of data. So some people call statistics almost math. They're like, it's not math, it's almost math. I'm like, why do you call it almost math? They said, really, it's more of a science that uses math. Statistics uses calculus. We won't get that far. We won't get into that in this class. But statistics does use calculus. I'm like, you use calculus? It's got to be, like, you use calculus and physics, and do you call physics math? No. Okay, fine. I'm not going to win this argument, so I'm just going to bow out of it. But it helps to make sense of data. I mean, if someone gave you an Excel spreadsheet with 5,000 rows of data and said, here, this is what I found. Just looking at that, would that really tell you much? No, you're going to look at that and say, I hope my computer can handle this. And that's a true story. I got a spreadsheet that had about 5,000 rows of data, and it took my computer about 10 minutes to open the spreadsheet up. Good grief. Take any longer, I could go take a nap, go grab dinner, and do everything else before you open it up. But I think that was the year I pretty much crashed my computer because of schoolwork. When used properly, statistical methods offer a set of powerful tools for gaining insight into the world around us. And it's used in different places. We already mentioned some before I even went to this slide. Business. I mean, if you're looking at, is my profit trending up or down? That's statistics. Medicine. Any trial for some kind of medicine that goes out, the FDA runs all these trials to see what side effects and how is the treatment really going to work and all of this stuff. Agriculture. So farmers may even be interested in which fertilizer will give me the greatest yield on my crop. They'll use statistical analysis. Social sciences like economics, psychology, sociology, stuff like that. Natural science, so what we think of when we think of natural science, biology, physics, chemistry, astrophysics, yep. And applied sciences. So it's used all over the place. And it teaches us how to make intelligent judgments and informed decisions in the presence of uncertainty and variation. So, if you've ever heard the phrase, the only thing constant is change, that's kind of where it comes from. The only constant is change. Just when we think we know something, well, oh, wait a minute. Well, I just learned how to log into Blackboard, and then you're going to change my password. Like I just memorized it. And then you change it on me. That's why I don't like those systems. It's like your password's only good for 6 months. And you log in 6 months later, please change your password. You gotta remember another one now? So why study statistics? Well, really, if there's a question that can be asked, there's probably a statistical study that you could do. So one question we might ask, can dogs help patients with heart failure by reducing stress and anxiety? I mean, that's where you hear about therapy dogs and all that type of stuff. Let's see, someone said. Hang on, give me 1 second. Thank you. Elizabeth. Yes, you may just sign out.
Right now?
Yes, you'll need your pen. Sorry, guys, I'm trying to. The virtual ones are saying they can't hear me, so I'm trying to figure out that way they can hear. Okay, so we talk. Can dogs help patients with heart failure? When people take a vacation, do they really leave work behind? What do y'all think on that one? When they take a vacation, do they leave their work behind? Not really? Okay, good. They can hear now. Perfect. Yeah, I can answer that last one. Not really. I mean, when I went on vacation, my mom's like, "Why are you bringing your statistics stuff?" I'm like, "Well, I want to be prepared for when I start teaching." But you're on vacation. Couldn't you have done that at home? I said, "Well, I do work on it at home, but I'm going to bring it with me so I can be ready. Besides, what am I going to do when y'all sleep till noon? And I'm up at 6 in the morning. I'll sit by the lake and do lessons." Now, basically, if there's a question, you can answer it using statistics. Okay, come on. Next. Oh, let's go over. There we go. So why should one study it? First thing is to be informed. You want to make an educated decision. I mean, kind of going back to the business scenario. If you're thinking of buying a $100,000 piece of equipment, you probably want to look at your data to see if your company's going in that direction. Like if you're an underwater welder and you're looking to buy a $100,000 backhoe, is that really going to be a good decision? Are there other underwater welders that use that expensive a backhoe? Probably not, being that you're working underwater, but who knows? So to be informed, you need to extract information from tables, charts, and graphs. Follow numerical arguments. So if all the data is saying, no, don't go buy that $100,000 piece of equipment, I mean, you kind of want to follow that, or you can just be like, oh, you know, you only live once. I'm buying it because I want it. Well, then that's on you. The data tells you to do otherwise and you still do it, that's on you. And understand the basics of how data should be gathered, summarized, and analyzed to draw statistical conclusions. I mean, I know I'm not going to get into politics in this class, but if you've ever watched the news, when they talk about elections, like, oh, this person, candidate A is leading candidate B by a landslide. It's predicted candidate A is going to win. And then you get to election night and like candidate B swamps candidate A. Like, but 2 nights ago you just told me candidate A is going to win. Where did you go wrong? Probably had to do with how they gathered their data. I mean, if you went to a known area that had signs that all said candidate A's name, and you ask, who are you voting for? You're going to get one answer. Candidate A. Candidate A must win then. Yeah. Anyways, to make informed judgments. That's another reason you should study it. So, one that would really impact y'all now, especially being that y'all are juniors and seniors, if you choose a particular major, what are your chances of finding a job when you graduate? I mean, I had a friend that wanted to be a lawyer, majored in pre-law, graduated, started applying to grad school and working under a lawyer, and they're like, you don't want to do this. Yeah, dude, I want to be a lawyer. She said, there's so many lawyers right now, we're not making hardly anything. And so she's like, okay, maybe I don't want to go spend thousands of dollars, tens of thousands of dollars getting my doctorates, my Juris doctorates to be a lawyer. Probably should look somewhere else. Yes.
I thought lawyers make a whole lot of money.
They usually do. And as with anything, if the market becomes too saturated and they get too competitive, that could drive prices down. So then people drop out, which means they can raise their prices back up some.
And like, I know in the programming field, like, more and more people want to be programmers. Like, eventually that industry gets saturated, right?
That's exactly right. But that's right. Yeah. Like if everyone decided at the same time, I'm going to be a programmer, then you could have a case where it's like, okay, there's too many people for the jobs available. That was the case with my major. I just stuck my head in the ground and said, no, I want to do that, so I'm going to try to do it. I mean, they told us there's not many jobs. I mean, actuarial science is cool and all, but you need to look at other things because there's this many people that want to be an actuary for this many positions available that's open usually. Like, well, you know what? I can fit into that many. I'm going to keep doing it. It didn't work out. And then to evaluate decisions that affect your life. So those are the 3 reasons to really study statistics. So kind of going beyond college now, many companies require drug screening as a condition of employment. With these screening tests, there's a risk of a false positive reading. Is the risk of a false positive acceptable? So that's just something if you were taking a drug screening and you knew, somehow you heard, that screening they're doing on you gives a lot of false positives, would you feel as comfortable taking that test? No. That's kind of like what we're in with COVID right now. I mean, it's known that those tests give a lot of false readings, false positives. And that's because usually what happens on tests like that is they will sit there and test them over and over and over and get that false positive rating down. Well, the world said, no, we need the test now. So instead of having all this time to tweak the test to make sure it gives an accurate reading, they're like, but no, we need it now. Okay, here. Well, now you're getting all these false readings that they may have it, they may not. You know, if they're experiencing symptoms, they probably have it. Personally, this is my personal opinion, the ones that are asymptomatic, I don't know. They'll say, oh, you tested positive, you're asymptomatic. But that's just me being skeptical because I know statistics. It's like I want to look at the data. Okay, so that was pretty much section 1.1. Why study it? 1.2 talks about the nature and role of variability. So, what is variability? Well, suppose we went into a convenience store to purchase a soft drink. And this example talks about cans. I'm going to do it in bottles. But most of the time when we go buy a soft drink, it's in a 20-ounce bottle, right? If you took and you scientifically measured every single bottle, do you think they would all be exactly 20 ounces? No. No, they wouldn't be exact. Some may have a tiny bit more, some may have a, tiny bit less. There's a range in there that the companies test for. They'll test their machines, and if they start seeing, wait, the last 10 I've tested have been under. Well, we need to shut this machine down, fix it, and then get it back going again. Because if customers found out that they're buying what they think is a 20-ounce bottle, and we're only giving them 16 ounces, they might get mad and not buy anything, so then we're losing money. The flip side of that, if they're giving you 22 ounces every time, you'll buy from them, but then they're losing a bunch of money because they're not able to sell more. So, no, there may be a little more or a little less in various cans or bottles due to the variability that's just inherent in the filling process. You're not going to get exactly that amount every single time. And that's how, if you remember, well, I don't know, y'all may not. This had been when, because I barely remember it, when Space Shuttle Columbia blew up upon re-entry. What happened was screws fell out of their heat shield, which caused the panel of the heat shield to fall off. Well, the reason the screws fell out is they were slightly too small, so they vibrated loose, and then boom. So, but for that factory, evidently, they were within their tolerance. That factory's tolerance, maybe they weren't within NASA's tolerance. Yeah, so while y'all are finishing that up, I mean, variability is pretty much universal. It's all around us. I mean, even like driving, especially if you have a digital speedometer, that speedometer will get off eventually. I mean, someone that I know got a ticket for going 40 in a 35 school zone. They said, "Officer, I have my cruise lowered down to 35 going through this school zone." And he said, "Well, I noticed you were going a constant 40 all the way through." They said, "Yeah, I have it on cruise." Now, why they have it on cruise in the school zone, that's another question for another day. But they said, "I just bought the car." I mean, he said, "Well, I clocked you at 40. But even then, the officer's radar gun, like my dad was a Houston police officer for 28 years, and he taught in the police academy in Houston. And he taught the officers, the radar may say, "Oh, they're speeding, their speed limit's 55 and 57. You can write them a ticket for going 2 over." He said, "Really, they may not. They may be going 55, but even that radar gun has a little bit of leeway to go." So that's what makes life interesting. The variability is what makes life interesting. I mean, if you bought, you know, if you ever bought a bag of chips, you open the bag, and it's pretty much all air, very few chips, because they didn't fill it correctly. You're like, ah, dang, I just bought a rotten bag, basically. But then you go to the store the next time and you buy a bag that's they filled probably a little too much. You felt like you just hit the jackpot. I mean, that's what keeps us on our toes. Okay, so now this is going to sound very stereotypical. I'm sorry. I'm just throwing this out there. So, next page. This is called If the Shoe Fits. Let's say they show us these two histograms. What these histograms are telling us, the bottom is the height in inches. So the x-axis is your height, y-axis is just the count of how many people. That's what that tells us, if y'all want to write that in there, since we haven't officially covered histograms yet. Bottom is height, y-axis is how many people. Okay, so if we had to make an educated guess based on what we know, they told us that one of these is the heights of gymnasts, the other is the distribution of heights for female basketball players. Which one of these graphs goes to which and why? And what are y'all's thoughts on this? Which graph could be the gymnasts? Which graph could be the basketball players?
Gymnast is B.
Gymnast is B. Why do you think gymnast is B?
Normally, if you play basketball, you don't get taller. So the taller people.
Okay, fair enough. Anyone want to argue the other point?
Like B is the basketball players.
Like B's the basketball players? What's your reasoning for that one?
I mean, not like a whole bunch too much tall. And they also have small shoe size.
Small shoe size, okay.
And also there's less people in there, so I mean you don't need like 40 people for basketball.
Those are all valid points. So they never actually tell us which one is which. They just want you to do like y'all just did, kind of say, you know, I think this because of this. Just get that thought process developing. So let's say we found a pair of size 6 shoes left outside the locker room. Which team would you go to first to find the owner, and why? So size 6 shoe, which team would y'all go to first?
Is it small for women or small?
The gymnast? And what was y'all's reasoning?
It's gotta be small and light, so probably have smaller shoe size.
Okay. Yep. Yep. I'd probably, again, these are just kind of open-ended, just trying to get that state an answer and then justify it. Now, suppose a tall woman tells you she's looking for her sister who's practicing with a team in the gym. Which team would you send her to? She's 5'11". Basketball, yeah. Yeah. Because she's tall. So informally, you just use statistical reasoning that combines your knowledge of the relationship of height between siblings, as well as height and shoe size with the information about height distributions. Now, for what it's worth, one thing I'll say, I I mean, I know they're talking about females here, but even as far as height and shoe size goes, I'm relatively short, but have a huge foot. So I'm 5'4", but wear a size 13 shoe. My parents tell me, they're like, if you ever want a water ski, just jump in the water and we'll pull you. You don't need skis. Go, thanks. Then when I went on that cruise I told y'all about, I couldn't fit my feet in any of the flippers to go snorkeling. Like, oh, your feet are big enough. Just wear your sandals. They'll act as your flippers.
The same shoe size as me.
Okay. Now, one thing I will caution you on, this part's not in your notes. If you want to kind of add it to the side, you can. Just something to keep in mind. Statistics can be misleading. People can make statistics say anything they want them to say, regardless of what your actual results are. And we'll talk more about this when we get into regression and stuff like that and correlation towards the end of the semester. But let's say we had a graph like this. Is there any pattern that you could possibly pick up on in this graph? No. So someone could do a study and that be the results. And they're like, but I need them to buy this. I need them to believe that my product is worthy. So then they just start taking stuff away. Now what do y'all think? Yeah, there's a positive correlation. That if that's what they wanted to show, if that's what you're thinking you're buying, and yeah, that's a good product. But all they did is they just manipulated the data to get their result, so they could sell you on it. And just always, I always tend to be skeptical of any results. It's like, where's the raw data? I want to look at it with my own eyes. Okay, section 1.3. We're actually moving pretty quick. So we might have some just chill time at the end of class. Okay. Now let's look at the data analysis process. So how are we going to do this whole thing? We want to research something. How do we do it? Well, kind of like, y'all may have to help me because I'm forgetting before I get into the data analysis. What's that process called in science? Where like you form the hypothesis.
Scientific method.
Scientific method, that's it. So kind of like that, y'all. Y'all have to form the hypothesis, test it, whatever that process is. I don't remember. It's been so long since I've done that. We have the data analysis process. The first thing you need to do is understand the nature of the problem. So it's important to have a clear direction before gathering data. If I just looked at my whiteboard up here and said, I have a problem with that whiteboard. Say, oh, what's your problem? But I want to do some statistical analysis on it. Okay, but what do you want to do? I don't know. I just want to do some analysis. Let's go. You're going to look at me and think, dude, I'm not going to go on a wild goose chase with you if you don't even know what you're doing. Get it together. So once you understand the nature of the problem, so maybe I want to compare that whiteboard with a different kind of material to see how well each one erases. Is this one going to leave a bunch of smudges compared to another whiteboard? Once I decide what to measure, or once I decide the problem, then I'm going to decide what to measure and how to measure it. So I want to measure the erasability of the whiteboard. And I'm going to do that based on how many smudges are left when I finish erasing. Okay, so I have my problem. I've decided how I'm going to measure it and what I'm going to actually measure. So it's important to carefully define the variables that are going to be studied and develop appropriate methods for determining their values. And that also kind of goes back to determining appropriate methods to getting their values. I mean, if I'm going to sit here and spray a fire hose at the whiteboard, do y'all think there's going to be any smudges left? No. There may not even be a whiteboard left if I get close enough. So that wouldn't probably be too appropriate. Then we've got to collect the data. So it's important to understand how the data is collected because as you'll see by the end of the semester, the type of data will kind of dictate the type of analysis you can do. Yes.
I missed the blank on number 1. It is important to have a blank.
Clear direction.
Clear direction. The blank on number 1. It's important to have a clear direction. Yeah. If I ever go too fast, y'all just let me know. Okay, where were we? There we go. Yes. Can you what? So those water bottles they gave y'all, are they like the just plain gray bottles? Do they have any like logo or anything on them?
It's got something on it that says like D50 strong. I don't know what it means.
Ah. D50 strong? Yeah, I couldn't tell you. To me, that means they were just donated. They were donated. Okay, so once we get all our data, then we need to summarize it and perform some kind of preliminary analysis. So we need to summarize the data and perform a just basic analysis. Try to see if we can see anything. Because what will happen is you summarize the data, you just throw a graph up there, you're like, oh, it looks like it's maybe doing this. Let me look into that further. And so then you dig a little bit deeper. And that initial, like I just mentioned, that initial analysis that you do provides insight into important characteristics of the data. So we thought data was going to be linear, and then we graph it and do a scatter plot, and it looks quadratic. Maybe there's something going on there. Maybe it was something we caused. Maybe we just totally didn't know what we were looking into. Could be different things. Once we do the preliminary analysis, we do our formal analysis. So once we kind of get an idea of where this is going, we've looked at it, formed our really specific questions and things we want to look into, then we do our formal analysis. And it's really important in this step to select and apply appropriate statistical methods. Inferential statistical methods. Really, every step is important. If you mess up on one of these steps, you're going to release your report at the end, and someone's going to call you out on it. Well, then your report just went down the drain. Got to start over. So this whole process is really important. Then the last step, you interpret the results. And this is a step that often leads to new questions. So I was doing in college a research project. I think it was like my senior year, huge project we had to do. And I was looking into the different causes for fatal vehicle accidents. And I got the data from an online website and from the National Highway Traffic Safety Administration, I think. And was looking, I'm like, okay, well, let's see what I can find. Well, if you watch TV or read anywhere, they say texting and driving is bad. So I think I'll start there. Is there any relationship between fatal crashes and texting and driving? I looked, and I'm like, at least according to this database, there wasn't hardly any relationship between fatalities and texting and driving. Like, that's odd. But the data set's official. So where are all these other companies getting their data from? And then I was like, okay, well, let's look at drunk driving. I mean, you watch the news or anything, read the news, drunk driver hit and possibly kill the innocent person. That one showed a little bit more of a significant relationship. The one that showed the highest was weather, like the rain, people driving too fast, in the rain, losing control. And then after the rain hit and the weather, then it was drug use. So people under the influence of drugs. Then alcohol, then texting and driving. I'm like, good grief. But anyways, I found my answer to one question, that spawned another question. Then I found that answer, then I looked at another question. And so that's just the cycle. It's a vicious cycle. So now let's kind of apply this to an example. Let's suppose we want to know the average GPA of high school graduates in the whole nation this year. What term would we use to describe all high school graduates? So we could collect the data from all the high schools in the nation. What would we call that whole data set? The what? The poll? What's that? Yeah.
What was the question?
What would we call like all those high school people that we collected data on? Population. That's right. It's the whole group of people we want information on. We got all of it. That term is the population. So the population is the entire collection of individuals or objects about which information is desired. And something that's going on now in the U.S., your parents probably have heard about it. There's been TV commercials. I've seen internet ads. They're doing what's called the census. And that's where they try to find out information about every U.S. citizen that's living here, and every, U.S. citizen and every, even non-citizens. Yes.
Like, doesn't census happen like every election year?
No, it's not every election year, it's every 10 years.
Oh,
So they're doing one this year in 2020. Then the next, they try to estimate it periodically. I don't know what that period is. But then every 10 years, so in 2030, they'll go through all this again. And then in 2040, they'll do the whole process again. And that's what depends a lot on funding. Oh, a bunch of people moved from California to Texas. Okay, so maybe we need to move some of our funding from California to Texas. And that's how many representatives in the House you get. It depends on the census. All kinds of stuff. How they divide the districts up to elect those representatives. So a census is performed to gather information about the entire population. So if you just remember, if it's about the whole population, it's a census. Just like we do in the U.S. So let's go back to our GPA example now. Let's suppose we still want to know their average GPA. We could collect this data from all the high schools in the nation. Why might we not want to use a census in this case? What are some problems that you could see?
Well, like, doing a census like more once or,
So why would you want to go around to every single high school in the U.S. and try to get GPA data? It's going to take up a lot of time. What else?
falsities?
Yep, falsities.
Yeah.
Yep. It's a lot of data. Falsities, meaning they could give you false data, incorrect data. What else? If it takes a lot of time, what else will it take a lot of? Manpower. What were you saying? Money. So a lot of time, a lot of manpower, a lot of money. There may be inaccurate data. Missing data. I mean, just basically, if it could go wrong, it probably would go wrong. And then you would have to go track them down, which means you're using even more time, money, people to go get all the wrong data. If you knew it was wrong. If you didn't know it was wrong, well then all your analysis could be off because you're using bad data. So if we didn't perform a census, what could we do? We can't sample everybody, so what could we do? Sample select them, that's right. We could use a sample. So a sample of the population, a sample is a subset of the population. And we select it in some prescribed manner. So a random sample would be, and we're going to talk in chapter 2 about the actual types of samples. But like you could just randomly say, go to a school, can I get your data? Randomly go to another school, can I get your data? Or you could break it into regions. So I kind of gave you all some hints there. What would a sample of high school graduates across the nation look like? Well, I said they could be from different regions or states. What else could be different about them?
The area.
The area, yeah. Number of students. Types of classes. What about students in particular? If they got all your data, what could be different? Demographics, yes. Gender, ethnicity, yep. Income, that could all be different. So high school graduates could be from different states, ethnicities, genders, etc. Okay. Anyone still trying to write this down? Okay. You can wait. Got it, Will? Okay. So just kind of continuing with this, we could collect data now. Instead of doing the whole population, we can collect it from a sample of high schools. So once we've collected the data, we went around, we figured out how we're going to sample, and we sampled it. What would we do with all that raw data? This kind of goes back to our, what's that? Organize it. Yep. We organize it, and then what else? What do we do with it, like when we get it organized? Find averages. We can find, what's that? Yeah, analyze it. So you organize it, you kind of get averages and just kind of an overview of the data, and then go start analyzing it from there. Okay, so this is where we stopped for third period. Do y'all want to stop here, or do y'all want to try to finish 1.3, and then y'all would have a little bit more free time tomorrow? They have like 10 minutes of free time, or no, 5 minutes of free time. What do y'all want to do? Just go on and finish 1.3? Okay, let's do it. Tomorrow we'll have a little, I'm going to probably try to get into 1.4 with them, so we'll just start at 1.4 tomorrow, get however far we got, and then the rest will be homework time tomorrow. So you'll have a good amount of time for your assignments. But since we're done with 1.3, if you wanted to have a real easy day tomorrow, you could go home and do 1.1 to 1.3, or for y'all it'd be just that assignment I gave y'all. For y'all it'd be that 1.1 to 1.3 assignment. If we finish 1.3, you could get that knocked out.
The assignment you gave us, so you wanted to do that whole tag thing, and that'll be our assignment?
Yeah, and then you'll put all your answers in Blackboard. Yep.
So our assignment is for 1.1 to 1.9, right?
Yep, the problem's 1.1 to 1.9. And I'll show y'all in that textbook. What's that? It'll be due Thursday. Because technically, I didn't know how all this was going to work, so I gave us 2 days to cover these sections. When I see now we probably didn't need all 2 days. But that's okay. That just gives y'all more time to ease into the semester. Okay, keeping going. Major branches of statistics. So there's 2 major branches. There's descriptive statistics, which that involves the methods of organizing and summarizing the data. And then inferential statistics. That involves making generalizations from a sample to a population. Now, you may be thinking, okay, so I'll describe it and then I'll make an inference. That may not always work for different reasons. I mean, if you were doing something comparing tennis players, do tennis players like being recorded? Does that actually help them become better watching their recording? Well, so you survey the high school competitive tennis players. See how they do? Do you think recording would have the same impact on a high schooler than it would a professional tennis player like Venus Williams? No. Do you think Venus Williams is even worried about the camera that's on her right then? No. She's worried about that tennis ball right in front of her. She doesn't care about the crowd, doesn't care. I mean, I'm sure she does, but y'all get what I'm saying. It's not bothering her. So you couldn't take a high school experiment and say, oh, all tennis players perform better. They're in different environments. Anyway, so descriptive statistics is the method, involves the methods of organizing and summarizing the data. So if we go back to our GPA example, if it contains 1,000 numbers, what are some ways that we could organize and summarize the data? What are some different ways we could organize it? Lowest to highest, yeah, you could sort it. Break it down in state ranges, that's a good. Y'all said it earlier, y'all said one of them earlier. Another one I'm looking for. The average. You can get the average of the whole data set. What did we look at earlier with heights? Yep. Histogram. Is it? Either way, yeah, I think it's histogram. But yep, that's okay. We'll actually really talk about histograms in chapter 3. You'll start throwing those words around like you're a pro. I'll do a histogram. No, I think this is better with a scatter plot. No, actually, I think the best way is to do a box plot. So those are different ways. You can make graphs. You can the range of the GPA. So, the range, the lowest to the highest. Calculate the average. Those are all different ways that we could organize and summarize the data. Okay. So suppose we want to know the average GPA of high school graduates in the nation that year. We could collect the data from a sample of the high schools in the nation. Could we use the data from our sample to answer this question? So, could we use the data from our sample to find the average GPA of all graduates in the nation? What do y'all think?
I was in a pretty small sample size for the entire nation.
Pretty small sample size for the entire nation?
Depends on the size of the sample. Wouldn't it?
Yeah, we collected 1,000.
Oh, 1,000, yeah. Doesn't seem practical.
Yeah, some high schools graduate with 1,000 in class.
Yeah, that's true. So, I would actually say yes, you could. Now, assuming you didn't go to one high school and just sample everybody there and that's it, you actually could. We'll learn about something called it's not a hard rule, it's like an unofficial rule that statisticians kind of use called the rule of 30. If you start getting more than 30 samples, or 30, I just lost the word, data points. I can't remember the one I'm looking for, but data points, it actually becomes what's called normal. So if you've ever heard of the bell curve, where it kind of starts, goes up, and then comes back down, we'll talk about that a lot this semester. Once you get about more than 30, things start looking kind of normal and smooth. So one way, without talking about statistics, to think of it, if you take, kind of going back to geometry, if you take a polygon, a regular polygon, say you start with a hexagon, then you start adding more and more sides, what does that shape start looking like eventually? A circle. It starts getting smoother and smoother. And then, you add 200 sides and you're going to look at it and think, I'm just looking at a circle. So, same thing with data collection. The more data points you get, the smoother things start looking. So, yes, you can, using inferential statistics, to answer that question. Could we use the data? Yes. We can use inferential statistics. So that involves making generalizations from a sample to a population. So based on the sample, let's say the average GPA for high school graduates was a 3.0. What generalization could be made?
If you're using the inferential,
Mm-hmm.
that every student would have a 3.0 average.
You're getting there. You're close.
I'm allowed to
You're close.
National average to 3.9.
The national average is a 3.0. That's right. Yep. I kind of figured that's where you were going. We just gotta be careful how we work. So the national average GPA for this year's high school graduates could be approximately 3.0. Now start thinking about trying to flip that around. because we go the other way. So if we find the national average is a 3.0, could I go and say Lufkin High School's average is a 3.0?
It's based on the evidence.
You actually couldn't. You can go from sample to population, but you can't go from population back down to sample. So could someone claim the average GPA for your high school is 3.0? No. Generalizations based on results of a sample can only go to the population from which the sample came from. So they can't get a sample and then without even saying the whole net, like we couldn't go sample NAC's GPA and say, oh, their average is a 2.0. So come back here and say our average must be a 2.0. It doesn't work like that. I mean, you could say their average is a 2.0, so everyone's average may be a 2.0. But even then, that runs into problems as we'll learn. You can't just sample one school and say, oh, that's the national average. Not quite. Yes.
So, how will it work is like, they would get like several samples in that, right?
That's right. Yeah. So we could like get our school to go up to NAC and get their average. Maybe go to other states and get their averages, and then we get other schools in other states maybe average everything together and then say, okay, the average is 3.0 or whatever. Regardless though, whatever you do, make sure your sample comes from the population of interest. If you're looking at the GPA of high school students, don't go to SFA and sample their GPA and include it in your study. They're not high school students, they're college students. So make sure your sample comes from the population you're wanting to look at. Okay, so any questions on 1.1 to 1.3? Any questions? Okay, y'all are a little bit ahead of third period. Can we go pass me the book? I'm gonna show y'all right quick. The way they do these problems is kind of weird. So sometimes they break them up based on sections. Sometimes it's after every section, multiple sections will group together and then have a group of problems. So like here, this section, let me back up. So if you want to write this down, you can. So in this case, I'll usually 1.1 to 1.9. They're all on page 8. And that covers the 3 sections we just talked about. But then you have our 1.4 at the end of that section when we talked about 1.4. See, there's 8 topics there. So then, sometimes I group them together, so if you're ever doing an assignment, you're like, wait a minute, 1.11 is the last one here, but it's because I have to go all the way through 1.12. Well, then start flipping and find the next problem set, there's 1.4. That make sense? So y'all will be 1.1.
Mr. Sheldon, would it be all right if I went and When you're ready.
Yep.
All right, thank you. I'm not Jake.
You too.
Sorry, I'm supposed to go online tomorrow.
The noise, yeah.
So, are we doing a Blackboard collaborate?
Blackboard collaborate.
Okay.
Yeah, we're gonna do that. Since you're already here, do you want me to give you all the copies I have and then let's let you go where the train?
Yeah, that would be nice.
Okay. This is the review that everyone's gonna do Friday.
Okay.
Because even though y'all are dual credit, I'm gonna tell the class this on Friday. Hang on.